What causes cascaded power grid failures and blackouts? Imagine a row of dominoes standing upright. If one falls, it can cause a chain reaction, knocking down many others. Power grids work in a similar way. When one part fails, it can trigger a series of failures across the entire system. This is what we call a cascaded failure, and it can lead to widespread blackouts. The process often starts with an initial disturbance. This could be a transmission line sagging and touching trees, a short circuit, or a generator tripping offline. Natural events like storms or extreme cold can also cause equipment to fail unexpectedly. For example, during the 2003 Northeast blackout, several high-voltage lines faulted because of sagging and low voltage, setting off a chain reaction. Similarly, the cold wave in Texas in 2021 caused equipment failures and spikes in demand that started cascading outages. When a line or generator trips, the power it was carrying needs to go somewhere else. The remaining lines then carry more load than they are designed for. If these lines are already close to their maximum capacity, this sudden overload can cause them to heat up and sag, leading to more faults and trips. This overload spread is a key reason why failures cascade through the system. Protective relays are safety devices that detect abnormal conditions and disconnect parts of the grid to prevent damage. But during a cascade, unusual power flows and voltage drops can trick these relays into thinking there is a fault, causing them to trip lines or generators unnecessarily. This protective action, while meant to protect equipment, can unintentionally speed up the spread of outages. Voltage instability is another factor. As the system becomes more stressed, voltages can drop below safe levels. Utilities may then cut power to some areas to stabilize the grid, a process called load shedding. But if the voltage drops too far, it can cause a total collapse of the system, leading to a blackout. Voltage issues often happen alongside cascades and can both cause and result from failures. The way the grid is built also matters. Highly interconnected networks can reroute power around problems, but this can also create complex dependencies. A failure in one part can quickly affect distant areas, especially if the network has certain patterns that are more vulnerable to cascading failures. Finally, the dynamic behavior of the system plays a role. Fast changes in power flows and the synchronization of generators can destabilize the grid within seconds. If generators lose their synchronization, they may trip offline, spreading the failure even further. These rapid dynamic effects are often the first signs of a cascade starting. To prevent these failures, utilities monitor real-time conditions closely. They use advanced sensors and automated controls to detect overloads or voltage drops early. They also analyze potential weak points in the network to identify critical lines that could trigger a cascade if they fail. During extreme weather, they take extra steps like winterizing equipment and diversifying energy sources to reduce risks. Load shedding and demand response programs are also used to lower stress during peak times. In summary, cascaded power grid failures happen because of initial faults, overloads, protective device actions, voltage instability, network structure, and rapid dynamic changes. Utilities work hard to understand and manage these factors to keep the lights on and prevent large blackouts.